In this segment, we're going to talk about dividing polynomials, and we'll touch a little bit on factoring polynomials as well as one of the options to do this division. Division is quite confusing for lots of students and lots of people in general, so I want to go back and just do a quick example here working with some whole numbers just to show some ideas that we're going to use later on with our algebra pieces. So if I start off with a question 15 divided by 5 and I want to do it visually with the manipulatives, I'm going to set up a question that looks something like this. And so I have my 15 here and my 5 here, and again I want to talk about if we do it in longhand, we often see our question written something like this, 15 divided by 5. So the same kind of setup is here. Our 5, which is my divisor, is out here. My dividend, which is my 15, is inside my two pieces of my division question. So there's my two pieces. And my answer, which is my quotient, is going to be found up here. So we're going to set it up the same way that we've done before. And so in this question I have 15 pieces. I want to divide them into 5 sections. So I've got 5 rows here, and in each row I'm going to have 3. So my answer to this question will be 3. But I just want to show you there's some different ways of getting that same answer of 3 that is going to be useful in our polynomials. I could rewrite my 15 divided by 5 this way. 10 plus 5 divided by 5. 10 plus 5 is still 15, and I'm dividing it by 5. My diagram would now look something like this. And I've divided my 15 up into a 10 and a 5. I'm still dividing it by 5. And this 10 piece gives me a 2, and this row of 5 gives me a 1. And so my answer is going to be 2 plus 1, which is still going to give me the answer 3. Mathematically, what would that look like? And it would look something like that. So I want to show that the 5, this line, this division line, belongs to the entire upper term. So this upper term here is a 15. I've now broken it down into two different terms, 10 and a 5, and this division belongs to both of them. So this is divided by 5 and this one's divided by 5, and we can show that by changing our diagram into the two pieces divided by 5. And I get my 10 divided by 5, which is this section in here, gives me my answer of 2, and my 5 divided by 5 gives me my answer of 1. So I can split this up, and the divisor belongs to both pieces of my dividend. And symbolically, we can also do this question by showing that we can take our 15 and change it into a multiplication question, which is another way of saying I've now factored it. Factoring is another way of saying changing an addition question or a term into a multiplication. And now I can do my canceling, and I still get my answer of 3. So these are all techniques that we can use with our regular number system, but we're also going to be applicable to our polynomials. So let's get started with some polynomials. So here's our first question, 2x plus 2 divided by 2. And if I want to draw this out with my diagrams, it would have to start off looking something like this, with my 2x's and 2 here inside, and dividing by 2, which is my divisor, out here on the side. Now let's take a look at what information it tells us and some clues. It tells me I have to divide it by 2, so I can't have 2 side by each down this side. I want to find a height of 2, so I have to rearrange it. And I'll have to rearrange these so that I can also get a rectangle. And if I do it like this, and I have the pieces down here, I have lengths that are not associated with this piece over here on the side. So I'm missing something here. So I can't arrange them this way. So now I've created a rectangle, and I have my rectangle divided by my 2, and what do I have to have across the top? Well, to make an x square here, it's 1 high by x long, so I have to have something that's x long here. And to make something that's 1 high and 1 across, I need to have a 1 here. So my answer is going to be x plus 1. Algebraically, we might look at it this way. We take the 2x plus 2 over 2. We say the 2x is over 2. So here's my 2x, and I have to cut it into two pieces. And my answer is going to be x. And here's my two individuals, and I have to cut it into two pieces because of this, and I get an answer of 1. So again, my answer comes out to be x plus 1. And the work would look something like this. A 2x over 2, the 2's cancel gives me 1x, and the 2 over 2 cancel gives me a 1, leaving me with x plus 1. And so I get 1x and my 1. So again, symbolically and concretely, it's all the same kinds of things, just making the connection so people can see what all the pieces are like. And as I did before, if we change it into a factoring technique, I factor the top first. What number goes into both 2x and a 2? A 2. So I factor out the 2, leaves me with an x plus 1. I've changed it into a multiplication question now, 2 times x plus 1. Now I can cancel my 2's, and again I'm left with x plus 1. Our next question, 3x squared plus 6x divided by 3x. We'll do it concretely first with the diagram. So initially, here's all my pieces, my 3x squareds and my 6x's, and I'm dividing it by 3x's. My 3x's have to be vertical because I want to get a height of x. If I had it turned the other way, that would be a height of just 1. So it has to be this direction. And so things don't line up the way they are right now, because this has a height of x and this only has a height of 1. So we have to rearrange this. I've got all the right pieces, but they're not in the right order. So by drawing it like this, we can make it work. I have heights of x's. All of these have heights of x's. And I have 3 rows, just like I need to have. So what has to go across the top? Well, to get an x squared, if I have a height of x, I need a width of x. So across the top, I have to have an x. And to get one of these, I need a height of x and a width of just 1. And so therefore, I need to put a 1 here and a 1 here. And so my answers is going to be x plus 2. And again, symbolically, if we want to do it, we take our 3x, and it belongs to each of the 2 terms along the top. So I separate them a little bit in my diagram. So it looks like that. And my 3x squareds divided by 3x gives me an x. And my 6x's divided by 3x gives me a 2. So my answer is going to be made up of an x and a 2. So again, I get my answer of x plus 2. And the work we might see is my 3 and my 3's cancel give me 1. The x squared divided by x gives me an x. So I'm left with 1x. There's my 1x plus, and my 6 divided by 3 is 2. My x divided by x gives me a 1. So 2 times 1 is 2. And there's my 2. And the other way is we could factor it first. 3x squared plus 6x. I can take a 3x out and leave that with an x plus 2. So now I've changed it to a multiplication question. So factoring means to change it to a multiplication question. And now I can cancel my 3x with my 3x, and I'm left with x plus 2 again. And this technique of changing it to a factoring before I cancel is very useful when I'm working with polynomials as opposed to just dividing by a monomial. We'll talk about that later. In this question, we're dividing by a polynomial now, a binomial. So we have 6x squared plus 3x divided by 2x plus 1. Using the manipulatives, it's quite simple to do. Let's do our diagram would look like this. And here we have our 2x's plus 1. So I'm dividing by 2x plus 1. Again, it has to be vertical because it has to be a height of 2x. And over here I have my 6x squareds plus 3x's. And clearly we have to rearrange this a little bit. So it would have to look like this. And so now I've got my rectangle. It's 2x's high, plus a 1 high, plus a 1 high. And I've got all my pieces. So across the top, what would have to have? I'd have to have 3x's to make my 3x squared, my 6x squareds. And it would look like that. And so even with a complicated divisor, which is a binomial, it's not too hard to get our answer. And here we see doing what we did before, taking the denominator and applying it to both of the pieces like we did in the previous examples, becomes problematic now. Because it's a binomial, I want to go x plus 2, or pardon me, 2x plus 1, and now I have to divide the 6x squareds into that, and it doesn't work. And my 3x's I have to divide by 2x plus 1, and that doesn't work either. So now this technique of splitting it up amongst the pieces does not work. And the factoring technique, if I factor something out of the 6x squared plus 3x is a 3x, what would be left would be a 2x plus 1. So now I've changed it into a multiplication question, and I've got a 2x plus 1 on the top, and a 2x plus 1 on the bottom, and I'd be left with my 3x. We can see that the model works very nicely. It doesn't matter if we talk about a monomial on the bottom or a trinomial on the bottom. The model works very well to find out what my answer is. The splitting it up piece works if it's a monomial on the bottom, but it doesn't work if it's a binomial or more on the bottom. And you have to understand how to do factoring before we can use this technique. So making sure that the students understand how my diagram fits and works first of all is important. And finally, we'll do this question, a trinomial divided by a binomial. 6x squared plus 7x plus 2 divided by 2x plus 1. And we draw our picture, and we take all our pieces. So here's all our pieces, but they're not in the right order. So our 2x plus 1 has to be vertical, so it looks like this. Our 6x squareds look like they might work. Our x's need some work though, so I know I have to line up some down here for my 1's. So I put my 3 down here, but now I still have some up here I have to worry about. And they can't be in this configuration, but if I turn them sideways, let's see what might happen. And that works. If I put them sideways, I have my 2 rows of x's, so it's x high and 1 across. Now I have to worry what to do with these 2 1's, and they just slide down here in my bottom corner, and now I've got my nice rectangle again. So if I have 6x squareds and 7x's and 2, and divided by 2x plus 1, what needs to be across the top? Well, I need to have 3 of these x's across the top, and 2 individuals, and let's just fix those up a little bit. And there's my diagram a little nicer. So my answer is 3x plus 2. And working with a relatively complicated question, my diagram's relatively simple once we understand how we have to arrange them so we make our rectangles. And our answer is very easy to read, 3x plus 2. As we discussed before, if I want to separate each one into its separate pieces, 6x squared over 2x plus 1 and 7x over 2x plus 1 and 2 over 2x plus 1, it's problematic with my diagram and it's kind of confusing to do. So that's not a good technique. And I could know, if I already know how to factor it, I can factor it and then do the canceling. But factoring is a slightly different topic, and we'll get to that in our next segment. So we've talked about using their diagram here, our manipulative, to help students understand how the division works. It works the same way as division with regular whole numbers works, and they can see where the pieces come from, which will be very helpful when they have to go and do factoring, which we'll talk about in our next segment.